Okay, histograms. Histograms are a way of showing continuous grouped data in a diagram. A bit like a bar chart in a way, but in a bar chart all the bars are separate and independent and don't touch. But with continuous data with no natural break between it, it must follow that the bars have to touch. Now up to grade D or so, the histograms that you've done are all of the same width. But here at grade A, sometimes you gather data and the class intervals are completely different. There'll be different bar widths. Therefore, it does make sense that the height of all bars with different widths should all represent a given frequency. So, for example, a very wide bar of a given height and a very narrow bar of the same height simply cannot represent the same frequency. When it comes to histograms with unequal group widths or class intervals, we have to take the area within each bar as the frequency, and therefore the Y value can no longer be called frequency, but is in fact called the frequency density. Let me demonstrate this. This is question 2 on page 107. This is grade A all the way. So let me just work with me on this one. I want to do the frequency density. And this will represent the y-axis when we plot it on the other page. So if you imagine the frequency density is here on the y-axis, and you've got the regular continuous variable along here on the x-axis, if the frequency density, call it FD for short, is the height across there, and the bar width is the width of it, we form a little rectangle, and the area just here in the corner is going to be the actual frequency within that bar. So that's where I'm coming from. It's only a rough picture, but I'm going to demonstrate it now. Therefore, how do you work out frequency density? Well, you take the area as you would of a rectangle and divide by the width there, and therefore you're going to get the height of the rectangle or frequency density. So here I go. It's the frequency is the area, so 120 to the first class, divided by the width of 100, and that will give me 1.2. Alright, so that's my first value along the y-axis. Next one, a frequency of 165, and this is the wages of factory workers, by the way. I jumped a bit too quickly there. So 165 divided by 50 people. There you go, from 200 to 250 is 50 people. That gives us 3.3. Next one, 182 people, bar width, class interval 50. 3.64. That's not going to be very easy to plot, but we'll have a go. Next one, 197 divided by class width 50. That gives us 3.94, just as difficult. Next one, 40 divided by 50 again. It's going to be 0.8. And finally we've got 6 divided by a class width of 200 there. And that's 0.03. It's going to be practically impossible to plot that, but we're going to have a go, aren't we? Alright, so these frequency densities are the heights along the y-axis. The frequencies themselves, as seen here, are the areas of the little bars just there, and the class widths will go along the x-axis and all the way starting from say 100 up to 600. So that's that lot, and that's me having produced the grid from before, just to save a little time. Now let's look at the first one. 1.2 ranging from 100 to 200. So 1.2 is our frequency density. Let's try and do this very carefully. Right, 1.2 is going to be 1.2468. Yeah, that's good. From 100 to 200, so I'll take 1.2 as there. Try and bring it down. There you go. That's the first. That's a little bit low. That don't know what to do about that. Anyway, imagine that's all filled in, and that's touching the 0. I just missed it a little bit. Next one, 3.3 from 2 to 250. So 3.3 from 2 to 250. So 3.3. It's going to be about there. From 200 to 250. I can play with it as long as I don't actually remove the pen. Take it on the floor. 250. Sort of there. Okay, it's the best I can do with that. As you can see, different heights, different widths. Next one is 3.64 from 250 to 300. So 3.64 it is. Oops, it's for later on. 3.64. 3.64. That's not going to work, is it? Start again. 3.64. Let's start from the 300. We can't miss, can we? 3.64. That's 3. We must touch 3.8. 3.6 is really hard to judge it. 3.62. 3.64. Okay, I'm going to try that. Okay, as long as you get the idea how to do it, I don't mind. And the next one's going to be 3.94 from 300 to 350. 3.94. So we start from 350, which will be about there, and 3.94. Let's start with 4. 3.8, 3.9. Always really difficult. Let's just try that, shall we? So I think you get the idea. Next one, 0.8 from 350 to 400. Lovely. 0.8, 400. So that's 1. So 0.8 is going to be 246. 246. Let's have a look. 2,468. Just there, I think. Yes. Oh, well, anyway, that should be touching. Sorry, I'm having a go, now. Next one's going to be 0.03 from 400 to 600. So 0.03. So that's going to be 0.2. That's 0.1. Again, very hard to judge. I'm just going to leave it there. I mean, just look at it. All this should be filled in. There should be no gap there at all. There should be no gap there at all. It's just that I can't. It's very hard to control this little pen. Anyway, so that's it. Unequal bar width, definitely. And also we've got some very unusual shape of bars. But that's effectively your histogram with unequal bar widths. Let's see if there's a question with that. Yeah, estimate the number of workers who earn more than £387.50. Well, I might use the diagram, or I might just use this table right here. Right, more than £387.50. Well, straight away I've got 6 people who earn over £400, but not between £400 and £600 straight away. Now, in order to earn £387.50, we know that some of these 40 people will be within this bar, which includes that £387.50. So imagine then I've got this bar. I'm just drawing it ever so roughly. Now this bar goes from 350, again I won't need to turn over to the histogram, to 400. And I've got this bar, again this skinny long bar here, again doesn't have to be accurate, just for calculation purposes. And I know I've got 6 people straight away within that last section who definitely earn more than that, because they earn more than 400. Now, imagine if you would, this line represented, again it's not accurate, this line right here represented the value £387.50. The question is, what is that part of the bar width just there? What is it? Well, from £387.50 up to £400, you're looking at £12.50. Try and make it fit just there. Right? So that little part is a bar width of £12.50. Now we know the height of that little bar is 0.8 from the frequency density before. Again, it's also on the histogram on the other page. So that's 0.8. So if I've got 0.8 multiplied by 12.5, let's just do a quick sum here. So 0.8 multiplied by £12.50 would give me how many people? Let's just do that quickly. So 0.8 times 12.5 equals, that's exactly 10 people. So I've got 10 people there who earn above, just shade them out, who earn above £187.50, and I've got these 6 people here as well who earn above that amount. So here's the answer. We have 10 people plus 6 people, that's 16 people who earn above £387.50. Now that's a lot to take in and study that one. There's a few more to come. Each histogram video will have something new to offer. So that's the first one, and the hardest thing of course is getting the thing to work on the computer. Secondly, it's decoding how you slice up part of a bar in order to find out an answer to a question that could be asked of you, and indeed will be asked of you. So just reiterate then. Take a chunk of the bar of the relevant part that's above £387.50. That leaves us a bar width of 1250 multiplied by the frequency density. Let me just label that frequency density. This little part here. That part is the frequency density times 1250 gives us 10 people. We already have 6 people in this last category, or this last group here. So 6 plus the 10, 16 people earn above £187.50. And now I'm going to stop.